Hi everyone, my name is Shin Musai, and today we're going to be doing example of a normal distribution. So we're going to calculate the probability for a normal distribution, and we know that a normal distribution is a type of continuous probability distribution. This question here says that suppose that x is normally distributed with a mean of 24 and a standard deviation of 6. Therefore, x follows a normal distribution of mean 24 and standard deviation is 6. The first part says to calculate the probability of x less than or equal to 20. So p of x less than or equal to 20. Now the first thing we must do is that we must standardize it, which means to take this specific normal distribution and convert it to a standard normal distribution. A standard normal distribution has a z-score and it follows a normal distribution with mean 0 and standard deviation of 1. The reason we standardize it is so that we can use a standard normal table to calculate the probabilities. P of x less than or equal to 20, all we do is say P of z, so we're converting it to a z-score, is less than or equal to x minus mu over sigma, and we have the values for mu, which is 24, and sigma, which is 6 for this question. So P of z less than or equal to 20 minus 24, because 20 is the x value from here, 24 is the mean from here, divided by 6, because 6 is the standard deviation from here, negative 0.67. So at this stage, we'll just catch a general standard normal curve. Apologize for the bad drawing. We know the mean in the middle of the standard normal is 0, and negative 0.67 should fall somewhere around here. So that's the area under the curve, which is this entire shaded area here. This standard normal curve is symmetric about the mean. So I know that anything less than negative 0.67 is the same as everything greater than positive 0.67. So therefore this, which says P of z less than negative 0.67, is exactly equal to P of z greater than positive 0.67. And look for 0.6, which is right here, and drive all the way across to 0.67, which is 0.2514, and that's my answer, 0.2514. So the probability that P of x is less than 20 is equal to 0.2514. Now, the second part of this question, I have to calculate probability of x greater than or equal to 22. First standardize it, this is equal to P of z greater than or equal to 22 minus 24, because 24 is the mean, divided by a standard deviation, which is 6. P of z greater than or equal to negative 0.33. Again, we'll just catch a general standard normal curve. Should be somewhere around here. We just calculate area of everything greater than this. Now, again, we would not find this value. We wouldn't be able to find this directly from the table, so we need to do some more adjustments. This area here, because the curve is symmetric, is exactly equal to everything less than positive 0.33, because the curve is symmetric, and therefore we can say that this area here is exactly equal to 1 minus P of z greater than or equal to 0.33, because we know the area under this whole curve here is 1. So if we minus this area here, then we will get the remainder, which is here. So 1 minus this area, so P of z greater than 0.33, is equal to this area. And this area is equal to this area, which is what we originally had. We need to find P of z greater than 0.33. So we look into our z table and we'll look for 0.3. Scroll across here to 0.03. So 0.33 is 0.3707. 0.3707. So the probability of P of x greater than 22 is equal to 0.6293. Let's do another question pretty quick, which I have to calculate. calculate P of x lying between 18 and 25, P of 18 minus 24 over 6 less than or equal to z square, which is less than or equal to 25 minus 24 over 6 is equal to, so we calculate this and we should get negative 1, and calculate this next, and this should be 0.17. We need to find the area of this shaded region, which is the probability of x lying between 18 and 25. We know the total area under the curve is equal to 1, so we can minus this probability here. So 1 minus probability of z greater than or equal to 0.17. We also minus in the probability of p of z, well, probability of z greater than 1, because this area here, p of z less than negative 1, is exactly equal to this area here, p of z greater than 1. So p of z greater than or equal to 1, because it is symmetric. So if we minus this area here and this area here, then we just remain left with the remainder. Look at normal curve 0.17 is 0.4325. 0.4325 plus, and I have to find out p of z greater than 1. So we look back in our normal table, p of z greater than 1, which is 0.1587, right here, 0.1587. 1587, and that would be 1 minus 0.5912, which is equal to 0.4088. So the probability of x lying between 18 and 25 is exactly equal to 0.4088 or 40.88%. Okay, so bonus time. So I created this Excel document here so that you could practice with a lot of other examples. So how this works is that whichever normal distribution you have, you can change the mean. So I'm changing the mean from 24 to probably 44, and I'm changing standard deviation to maybe 9. And therefore, if I calculate the probability of x less than, say, 38, the answer is 0.2514. So it's calculated automatically for you. If I calculate the probability that x is greater than, say, 35, that's a calculated probability already for you, which is 0.84. Or if I calculate the probability of x lying between 40 and 55, then the answer is 0.55. So this Excel document calculates the probability for you. You just need to enter all the details and it does the job for you. So it's a good way to double check your answers and make sure you're correct. Have fun. Okay, so I'm going to put the link for this Excel document in the description below so you can check that out. Hi everyone, this is Shin Musai. So you have just completed watching my video there on the normal distribution. If you enjoyed it or it helped you in any way, please make sure and like this video and hit the subscribe button. It will be really appreciated. So thank you very much for watching the video. See you in the next one. Have a great day.